Hi everybody, Mrs. Pesic here. We are looking at Chapter 1, Functions and Their Graphs, Section 1.1, Rectangular Coordinates. So you know that the rectangular coordinate system is also known as the Cartesian coordinate plane, named after René Descartes. And so in the Cartesian coordinate system, you have two number lines. Basically, you have a x-axis and a y-axis, and they are perpendicular to each other, and they meet at the origin. So the origin is right here. That's 0, 0. And when we have a positive direction in the x and a positive direction in the y, if we plot something up here, for example, that's going to be a point in quadrant 1. If we were to plot a point where we're going to the left and then up, then that's going to be in quadrant 2. All right, and if we're going to go to the left and down, we're going to be in quadrant 3. And if we go to the right and down, we're going to be somewhere in quadrant 4. So let's see, how many words of this did we use? I talked about quadrants, we mentioned origin, ordered pairs. Let's just quickly recap. If we are in quadrant 1, an ordered pair is going to be of the form positive, positive. If we're in quadrant 2, the ordered pair is going to be negative, positive. In quadrant 3, the ordered pair is going to be negative, negative. And if we're in quadrant 4, the ordered pair is going to be positive, negative. All right, I think you're all good with plotting points. And the other thing is we should talk about how to do a scatter plot. So when you're doing a scatter plot on graph paper, I'm expecting that there is a homework problem that is a scatter plot that you have to do on graph paper, and I'm expecting a couple things. First of all, I'm expecting that you are going to label your x-axis, like years or whatever it is, and then let's say you're going to label your y-axis, which might be number of people or something like that. So you're going to label your axes. Next thing is you're going to make sure that you have increments and that they're all the same on the x-axis. For example, maybe years I'm going up by 1, like this, year 1, year 2, year 3, and so on. And for number of people, maybe on this axis, I want to go up by thousands. So that's 1,000, 2,000, and so on. You just need to be consistent all along your x-axis, and you need to be consistent all along your y-axis. If you want to, let's say your data doesn't start until, 20,000 people, and it goes from 20,000 to 25,000, then on your y-axis, you could put a break in the graph and have it start at 20,000, then go to 21,000, and so on. So that's indicated there by a break in the graph. All right. Okay, we will talk about how to do scatter plots on the TI Nspire. We'll talk about that in class. All right, so moving along, a little reminder of the Pythagorean theorem. I know you learned this in geometry, but the idea is if you know any two sides of a right triangle, you can find the third side. All right, and the formula is a squared plus b squared equals c squared, or more precisely, we could say, that the leg squared plus the other leg squared is going to be equal to the hypotenuse squared. All right. We also need to be reminded of, in this section, the midpoint formula. The midpoint of a segment from x1, y1 to x2, y2 is given by, we use capital M for midpoint, is given by x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So, for example, if we want to find the midpoint between, let's say, -1, 4 and 3, 10, for example, then we would say, oh, we want to say -1 plus 3 over 2, comma, 4 plus 10 over 2. And that would get us to, what, 2 over 2, comma, 14 over 2, which is really, the ordered pair would be 1, comma, 7. That would be at the midpoint. All right. So let's take a look at this example. During the third quarter of a recent game, the university's quarterback threw a pass from the 32-yard line, 40 yards from the sideline. The pass was caught by the wide receiver on the 3-yard line, which was 15 yards from the same sideline. So how long was the pass? So in this case, we're going to have to use the distance formula to get the distance. So here's my rough sketch of a football field, and the quarterback is somewhere on the 32-yard line. So let's say the 32-yard line, quarterback is right about here. Here's my 32-yard line. And the quarterback, I'm going to place him on that yard line, and he's about 40 yards from the sideline. So I think I could just say, you know, this distance from here to here is 40. All right? And then he's throwing it to the wide receiver, who is over here on the 3-yard line. So I'm drawing my 3-yard line. Let's say 3-yard line is about here. And let's put that wide receiver here. And the wide receiver is 15 yards from the same sideline. So let's say this distance here is 15. So really, if we picture that this is, like the x-axis here, and this is like the y-axis here, and this point right here would be 0, 0, and so the quarterback ordered pair right here, I'd have to go 32 units over and 40 units up. So I think this quarterback is at the order pair 32-40, and he is throwing it to the wide receiver. Here's the pass right here. It's going like this to the wide receiver, and so that wide receiver could be thought of as at the ordered pair 3, 15. So we're trying to get the distance between 32, 40 and 3, 15. Let's remind ourselves what the distance formula is. It is the square root of x2 minus x1 squared minus y2 minus y1 squared. And so in this case, we could call, doesn't matter which one we call which, I'll call this one x1, y1, and I'll call this one x2, y2. It makes no difference which one is x1, y1, and which one is x2, y2. So when I plug those in, I get that the distance is going to be 32 minus 3, quantity squared, plus 40 minus 15, quantity squared. And if I simplify that a little bit more, I get 29 squared plus 25 squared. Hopefully I'm doing my math right. And then I'm grabbing my calculator, and I am doing 29 squared plus 25 squared. So that whole thing is 1,446. And then that is approximately what? I'm telling my calculator to do the square root of that answer, and I am getting about 38.3, in this case it'd be yards. All right, so that's how you can use the distance formula to solve this real life problem. And let's take a look at this. If we have this ordered pair and we want to translate this triangle 2 units down and 3 units to the right. Well, first, before we handle that transformation, let's talk about this triangle. We see that we have the ordered pairs. This is 1, 0. This is negative 2, 3. And this is, looks like it's 3, 3, 7. If we want to translate those 2 units down and 3 units to the right, first of all, if we're translating down, then we need to change the y-coordinates. And if we're going down, we've got to subtract 2 from each of the y-coordinates. So let's draw that in. We're going to subtract 2 from the y-coordinate here, and here, and here. And then if we're going to shift 3 units to the right. Shifting to the right is a change to the x-coordinate. And if we want to go to the right, that's adding 3 units to the x-coordinate. So I really want to add 3 to this x-coordinate, add 3 to this x-coordinate, add 3 to this x-coordinate. By the way, that's supposed to be 2. Doesn't look like it. Now it's better. Okay, so now when we get those new ordered pairs, I'm going to write those off to the side here. I'll write them right below. So this is going to be 6, 5. This new ordered pair is going to be 4, negative 2. And this ordered pair is going to be 1, comma 1. So let's see how that works if I plot those 3 points. Let's see. I think I want to plot 6, 5. 1, 2, 3, 4, 5, 6. That's going to be right here. Okay. And then I want to plot 4, negative 2. 1, 2, 3, 4. Negative 2 is going to be right here. And then I want 1, 1, which is right here. So let's see what happens if I try and make this triangle. And I'm hoping you're doing all of these good notes on graph paper, but I think I want this to connect here, this to connect here, and this to connect here. So overall, this would be our new graph. It's been shifted. Each point has been shifted 3 units to the right and 2 units down. And I'm actually thinking that looks pretty good. So that would be our answer for this problem. We have translated this triangle according to the directions. Okay, so let's talk about the formula for percent increase and decrease, because some of the homework problems ask you to do that, and so maybe you're not familiar with this or don't remember it. So basically, it's new minus old over old, and then you could say like times 100 to get a percent. All right. So for example, if let's say the rent at some apartment building was $650 in the year 2016, and then the rent goes up to $825 in 2018, then what would be the percent increase in the rent? Well, this was the old rent. This was the new rent, and so we would use this formula. We would say 825 minus 650 divided by 650. And once we get that answer, we're going to multiply that by 100. So grab your calculator, do this along with me. So I am doing 825 minus 650. I'm getting 175 over 650. And I'm going to multiply that by 100. So if I do 175 divided by 650, and I want a decimal for that, I am getting 0.2692, for example. And then if I multiply that by 100, I'm going to get that this was a 26.92% increase. Now, if the rent had gone down instead of up, for example, then when you do new minus old, you're going to get a negative number. And so that would indicate a percent decrease if you get a negative number. All right. Okay, and that's it for this video. Your homework is listed here, and I will put it on Plus Portals and Blackboard. Notice a couple things about this homework. We're doing section 1.1. Not 8.1, right? So this is in the front of the book, not the back of the book, and your homework is page 8, not page A8, all right? And these are the problems that I'm asking you to do. I know 16 is a problem that you're going to need graph paper for, so I put GP by this, and there may be others that you need to do on graph paper, so be watching out for that. All right, thanks for watching. Have a great day.